Okay, hello everybody. Um, I'm going to be doing the lessons in these videos, okay? The next 2 weeks, you guys are going to be learning about quadrilaterals, okay? Remember what a quadrilateral is? Quad meaning 4, okay? Quad meaning 4, and lateral meaning sides, okay? 4 sides. So a quadrilateral is any shape that has 4 sides, any polygon that has 4 sides. Okay, now these next 2 weeks you're going to learn about quadrilaterals. There are 4 main categories of quadrilaterals that we're going to learn about, okay? And the first one is parallelograms, okay? So this set of notes, we'll go through them today in this video. It may not take the entire class period, and tomorrow you'll get a chance to practice this, okay? I'm not going to push you guys quite as hard as I'm pushing my algebra kids, since we don't have an end of course exam to get ready for in May. You guys, we can take it a little bit slower. So these videos may not use up the entire class time. If you do have time at the end of class, obviously find a way to keep yourself quietly entertained and do not become a problem for the substitute teachers. Okay, for Miss Ellison, Miss Covington, or Miss Luna. Okay. So I guess, yeah, let's get started here with parallelograms. Okay, the first term, there are 3 terms here that we're going to talk about. Quadrilateral, we already kind of discussed that just now. Quadrilateral has 4 sides, okay? It's anything with 4 sides, any closed figure with 4 sides. It can be a square, a rectangle, a trapezoid, a kite, a parallelogram. You know, there's all sorts of options, but there are 4 main categories that we're going to talk about over the next 2 weeks. Today's category is a parallelogram. A parallelogram is a quadrilateral, meaning it's a 4-sided figure, in which the opposite sides are parallel. Okay, so there's all sorts of versions of this. Okay, the most generic example is the one where you've got something kind of like this, where this side and this side are parallel, and this side and this side are parallel. Okay, now you're gonna have to excuse my writing on the iPad. I'm using a stylus and it's not exactly perfectly accurate, so I'm gonna write as good as I can, but don't judge me and pay attention to what I say while I'm drawing and while I'm writing, and you'll have a easier time of understanding what's going on. Okay, so a parallelogram is a 4-sided figure, a quadrilateral, which has 2 pairs of parallel sides. The opposite sides are parallel. Okay, and then we need to define this word diagonal, because we're going to be looking at the diagonals of these shapes. Okay, so if let's say I have a rectangle, or any parallelogram for that matter, a diagonal is, I'm going to draw it in blue here, the diagonal is the line that connects one corner to the other. Okay, one corner to the other. Okay, so the diagonals connect one corner to the opposite corner, or vertice. One vertice to the opposite vertice. Okay, so let's see if we can apply just that basic knowledge to this example 1 right here. Okay, they say the parallelogram at the right has 4 vertices, and it wants us to name those 4 vertices. Okay, these are just points, so there's no special symbol. What are our 4 vertices? We've got N, M, P, and Q, right? Those are the 4 vertices. Okay, I usually try to do alphabetical order as much as possible. I think I messed up. I messed that up. It should be M, N, P, Q, but whatever. Okay, like I said, as the most I can, I try to go alphabetical order. It's not crucial. It doesn't make the problem wrong or anything like that. So we would name this. There's a special symbol for when we say parallelogram, MNPQ, or quadrilateral or anything like that. We use this symbol right here, okay? You see it in letter C, but it's this symbol right here. You make a little parallelogram, and then you name it. Parallelogram M, N, P, Q. Okay, that's how you would name the parallelogram. Okay, and it's very specific. Okay, you got to use that symbol. Okay, the symbol means parallelogram, so that we're not thinking, oh, this is just some random quadrilateral. We know that it is a parallelogram. Okay, the opposite sides in parallelogram MNPQ, there are two pairs, right? Opposite sides. We've got MN in, and that is a segment, so you do have to put the little symbol above it, MN, and its opposite side would be PQ, right? And then we have MQ, and its opposite side is NP, right? So we make sure to put our little symbols to show that those are line segments. Okay, what about the opposite angles? If I gave you angle M, what angle is opposite from it? Well, hopefully you said angle P, right? And if I gave you angle Q, what angle is opposite from it? Hopefully you've said angle N, right? So when we're talking about opposite angles, opposite sides, they're the sides or the angles that are across from each other, across the shape. Okay. Now, consecutive angles. Okay, consecutive angles are ones that come right after each other if you're going around the shape. If I start at angle M, what would the next angle be? Okay. Well, you have two choices. If you're moving clockwise, it would be angle N, right? If you're moving the other way, your consecutive angle would be angle Q. Okay, so you've got angle M and N, you've got angle N and angle P, you've got angle P, angle Q. Oops, I forgot my angle sign. Let's back up. Let's see if that, nope, that's not going to work. Okay, so let's back up. Angle Q. And then we've got angle Q. Gosh, I keep forgetting my angle sign there. And angle M, right? So we have 4 pairs of consecutive angles, and you can go any direction, okay? You can go either direction as long as it follows. You know, if you start clockwise, keep going clockwise. If you start counterclockwise, keep going counterclockwise, okay? Now, what would the diagonals of this parallelogram be? Well, it would be the line that connects M to P. That would be one diagonal, and the other one would connect N to Q. Okay, so those are your 2 diagonals in this shape. Okay, so identifying the parts is important because we're going to refer to those parts when we start looking at the qualities of a parallelogram. Okay, so identifying its parts, its sides, which sides are opposite from each other, which angles are opposite from each other, what are your consecutive angles, and then last but not least is the diagonals. Okay, so knowing what those parts are, these names that they're called, right? Opposite sides, opposite angles, consecutive angles, and diagonals. Those are important terms to understand about quadrilaterals. On this page, okay, if you turn to the next page, we're on the next page now. If you turn here, it says that parallelograms have 5 properties. A property is something that is true about this shape. Okay, has 5 properties. Okay, these 5 properties are true for any parallelogram. Any parallelogram. Okay, so the opposite sides. Remember, our opposite sides are the ones that are across the shape from each other. Let's name this real quick. Let's give it names. Let's say A, B, C, and D. Okay, and then this inside point right here, we'll call it E. Okay, this inside point where the 2 diagonals meet. All right, so opposite sides are parallel. Okay, so if I say that AB, what side would it be parallel to? DC. That's right. What about side BC or CB? It would be parallel to AD. That's right, okay? So we've got parallel lines as our opposite sides, okay? Now those little arrows along the line, those indicate parallel lines. We've seen those before when we're doing our parallel lines cut by transversal, okay? That's the first property, that opposite sides are parallel, okay? Then it also says the opposite sides are congruent, okay? They're congruent. Congruent, remember, means they're the same measure, okay? So this side is congruent to this side, and this side is congruent to that side, okay? Remember, the single tick mark will match the other side that has a single tick mark. That means they're the same length. The double tick mark matches any side that has double tick marks, okay? So opposite sides are not just parallel, they're also congruent. The third property is that opposite angles are congruent. Okay, opposite angles. Let's see if I can't change colors here. Opposite angles. That means angle D here should match angle B. The whole angle, right? Not just the little parts cut by the diagonals, but the whole angle B and the whole angle D. Those two parts are congruent. So I put one arch in both of them. And angle A, then, I'm going to give two arches, should be congruent to angle C. Okay? So opposite angles are not only, opposite angles are congruent. They're the same measure. Okay, so if angle D was 45 degrees, angle B would have to be 45 degrees, and so forth. Okay? So opposite angles are congruent. Opposite sides, opposite angles, they're all congruent. Okay? Number 4, property number 4 says that consecutive angles are supplementary. Consecutive angles, remember what that meant? So consecutive angles, that means that if I take angle A and add angle B, okay, sorry, my little angle sign was terrible. Let's try that again. Angle A and angle B. If I put them together, what does it mean to be supplementary? Well, that means they add up to 180. Okay, that's also true for angle B and angle C. They add up to 180. Same thing for C and D, same thing for D and A. Okay, so angle C plus angle D is 180. And the same thing for angle D plus angle A is 180. Okay, so that's true for all the angles. The consecutive angles are supplementary. If we take two angles in a row going around the shape, they should add up to 180. Okay, and the last property about parallelograms, is that the diagonals bisect each other. Do you remember what it means to bisect something? Okay, bisect means to cut it in half. If I cut AC in half, okay, if it gets bisected by the other diagonal, that means this and this are congruent to each other. But it doesn't just say one diagonal gets cut in half, it says that they both bisect each other. So that means this section is congruent to this section. Okay? So that point E is in the middle, it's the midpoint of both of those diagonals. Okay? So we have these 5 properties that are true for any parallelogram, no matter what it looks like. If you've got a parallelogram, these 5 things are true about it. Okay, so let's see if in example 2 we can do everything they ask us. In example 2, they say complete each statement regarding the parallelogram below. First, they want us to name it. Remember, when we name a parallelogram, we've got to use the parallelogram symbol. So we drew our little parallelogram symbol. And then we're going to name this with its 4 vertices. What are the 4 vertices? Well, we've got A, B, C, D. This would be parallelogram A, B, C, D. My preference is to put it in alphabetical order. You don't have to. That's just my preference. Now, which side would AB be parallel to? Remember these vertical lines right here? These little vertical lines right here, this means parallel. So they're saying AB is parallel to what? Well, hopefully you're thinking DC. Okay? Segment DC. Those 2 lines are parallel. Okay? What about, they say DA is congruent. Remember, this little equal sign with a squiggly line on top means congruent. So segment DA is congruent to what? Well, if you look up in our properties, it says opposite sides are congruent. So DA should be congruent to CB. Okay, what about angle CDA? Okay, this angle right here, they want to know what is it congruent to. Well, according to our properties, number 3 says our opposite angles are congruent. So this angle right over here, angle B, okay? And since there's more than one line at B, we have to label it with 3 letters. So we're going to say angle CBA is congruent to CDA. And last but not least, letter E says segment DE is congruent to what? Well, DE is this part right here. The diagonals get cut in half, so that forces this EB right here to be congruent to it. Okay? EB. Alright, so if you can visualize a parallelogram or draw one down like this, you should be able to mark it up with all of its congruent parts, all of its parallel parts, and things like that. Now, what happens when we throw in some algebraic expressions and ask people to solve this? Well, it just means that we get to do a little bit of work. It says ABCD is a parallelogram. All right, so I'm going to draw that since there's not one for me. Okay, we've got a parallelogram. Hey, that's pretty good if you ask me. Okay, we've got A, B, C, D. Okay, so A, B, C, and D. Now they tell me that angle A, this guy right here, is X degrees. Okay? Then they tell me that angle D right here, this guy, is 2x minus 3. Ooh, that was an ugly 3. Let's try that again. I'm going to do the whole expression again. 2x minus 3. Okay? Now, what did our properties at the top of this page, what did they say about consecutive angles? Remember, A and D, angle A and angle D, those are consecutive angles because they're right next to each other on the shape. Okay? These are consecutive. Be sure not to get confused between consecutive and congruent. You really have to listen to the words, right? Okay? If these are consecutive angles, the properties at the top of the page, okay, this property right up here tells me that consecutive angles are supplementary. Well, if these are consecutive angles, then they should add up to 180. So x plus the 2x minus 3 equals 180 degrees. Okay, now we have a simple algebra problem. We put our like terms together. We've got an x and a 2x. So that's 3x minus 3 equals 180. We do our next step, which is to add 3 to get rid of the minus 3. This makes 3x equals 183. And last but not least, we have to divide by 3, and we get that x equals 61. That was ugly. Let's try that one again. I was trying to fix it, and it didn't work very well, so 61. So our x in this problem is 61. Okay, and you could double check that. You could plug it in here and say that angle A is 61. Okay, so 61 plus the 2 times 61 minus 3 should equal 180. And if you work that out, you get 61. This makes 122. Subtract 3 from that. You get 61 plus 119. And sure enough, that does make 180. Okay, you guys can check me in your calculator. Okay, you need your calculator, right? Because we're going to be doing a couple more. Okay, so if you don't have your calculator, go ahead and take about 30 seconds to grab it. Go, 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 go. Go get your calculator. Calculator, calculator, calculator. Okay, while you're getting your calculator, I'm going to switch to the next page. Okay, so everybody turn to the next page with me. Okay, on this page, we're given a couple more examples we need to work through. You may have to flip back and forth between the previous page or leave your notes open because I think the properties are on the back of the first page and this is the front of a new page, so you can set them next to each other. Okay, we need to know what those properties say so that we know how to set up our algebraic expressions or our equations and things to solve. Okay, so they say XYZW is a parallelogram. Okay, so I'm going to draw it. We've got X, let's see, parallelogram, X, Y, Z, W, with diagonals X, Z, okay, so X connects to Z, and Y, W, so Y connects to W, and they intersect right here at, and they're calling that point A. Ooh, that was bad. Let's try that one more time. No, there we go. And they call that point A. Okay, so we've got parallelogram X, Y, Z, W, the diagonals X, Z, and Y, W, and they intersect at point A. They say if XA is 3 meters, or 3m, I'm sorry, not meters, XA is 3m, and ZA is 5m minus 4. Well, what do we know is the relationship between XA and ZA? Well, if they got bisected by the other diagonal here, if they got bisected, that means it got cut in half. So this part should equal this part. So couldn't I say 3m equals 5m minus 4? Isn't that allowed? Okay, because it says that the diagonals bisect each other, cuts them in half. Okay, so the two parts are congruent. Alright, so we start solving this problem by subtracting our 5m. Now I know I normally tell you guys to move your smaller guy, but in the interest of saving work, you know, having to do less work, let's just subtract our 5m, since there's only m on this left side. This would make a negative 2m equals negative 4, because that goes away. Okay, and last but not least, we would divide by negative 2, and we would have to remember that a negative divided by a negative makes a positive, and 4 divided by 2 is 2. So m would equal 2. You guys can check me on your calculator, or you should be checking me on your calculator, because you should be doing the work yourself as well. Okay, 5, 6, and 7. Okay, we're finding the values of x, y, and z. Okay, so I'm going to zoom in here and just look at number 5 first. Okay, my answer blanks are at the bottom here. All right, we're going to look at number 5 by itself first. Okay, they tell us that these are parallelograms. Okay, for each parallelogram. Okay, that means those 5 properties we learned on the other page apply to these figures. Okay, what does it say about opposite angles? Okay, what does it say about opposite angles? Well, I'm pretty sure it says opposite angles are congruent. So if this angle is 80, what should x be? That's right, 80. So x is 80. Okay, how does this 80 relate to z? Well, they're consecutive angles, aren't they? If they're consecutive angles, I believe it tells us that consecutive angles are supplementary. So 80 plus z equals the 180. Okay, so z would have to be 100. Okay, now you might be asking, Mr. Hahn, what about y? It's not even on the inside of the shape. I bet we've learned something that would help us out here. Okay, a couple things actually. I'm going to go with, I'm going to go with this. Look at this right here. If I were to extend this out, don't I have 2 parallel lines, right? Because it's a parallelogram, being cut by this transversal right here. Oh my gosh, he's bringing back something we learned 3 weeks ago. Oh no. Okay, we've got parallel lines cut by a transversal. What type of pair would you say these two angles are? Well, they're on the interior, right? They're in between the 2 parallel lines, and they're on alternate sides. One's on the left, one's on the right. Alternate interior. Alternate interior angles are congruent. So if x is 80, then y has to be 80. Okay? See if you can apply these same ideas to number 6 here. Okay? Let's try number 6. Think about the information you already know. The whole shape is a parallelogram. And this guy right here, these two are opposite angles. So what does z have to equal right away? 120. Okay. Okay, what else? What could we do? Is there a relationship between this 35 right here and that y? If you think about our parallel lines cut by transversal, we've seen a problem like this before. If we've got these parallel lines cut by this transversal, then alternate interior angles are congruent. So y would have to be 35 degrees. So if we know z and we know y, What sort of shape do z, y, and x make all together? A triangle. So if z is 120 and y is 35, and then we add in x, what should our total be if we're talking about a triangle here? Hopefully you said 180. Okay, this makes 155. And then we subtract the 155, you get x equals 25. Okay. Now, I know that we just sort of jump back and forth between triangles and quadrilaterals. That's okay. We know information about triangles. We know about triangles. We've done them for the past couple weeks. Okay. We played with triangles. We know about polygons and what their interior angles have to add up to and things like that. So we're allowed to use that information. Okay, we are allowed to use any information we have previously learned. All right, how about this one? Okay, in my opinion, z is going to be the easiest one to find. Why would I say that z is going to be the easiest one to find? Well, because 70 and z are a linear pair. They make a straight line together right here. Okay, so if this is 70, what does z have to be to finish off the 180? 180 minus that 70 gives us 110 degrees. Okay, so if z is 110, that means this guy right here is 110. Interesting. Okay, that does us some good, but doesn't do us a whole lot of good yet. What about x? What would x relate to? Think about parallel lines cut by a transversal. I'm showing you guys some shortcuts for your practice set tomorrow. Look for these types of patterns. Even though we're dealing with parallelograms, look for information we've learned before. Okay? How are 30 and x related? They are alternate interior angles. So they are congruent. X has to be 30. So I know my 110, my x, which is 30, and my y have to make 180 degrees together because of this triangle right here. So I start with 180, I take away 30, that's 150. I take away 110, that leaves me with 40, which is my y. Okay? Let's do one more example and we'll be done for the day. Okay? Alright, this one gives us a lot of information all at once. We've got to be able to siphon through all the information, okay? It says WXYZ is a parallelogram. Okay. Measure of angle ZWX is B degrees. We're going to have to figure out B here in a little bit. Okay. ZWX, that's this guy right here. This guy right here is B degrees. And WXY, that's this guy up here, is D degrees. Alright, so we'll figure this out here in a second. Let's start with A. How does A relate to this 15 right here? Well, this diagonal, according to the properties of parallelograms, this diagonal gets cut in half by this diagonal, and vice versa. So if it's cut in half, if this is 15, then this has to be 15. So A is 15. That one was easy. Let's jump up to C. Let's take care of our sides before we get into our angles. How does 2C relate to 22? Well, according to our properties of parallelograms, opposite sides are congruent. So 2C equals 22. And hopefully you can do that math in your head. C would have to be, oops, that looks like a 17, doesn't it? It's supposed to be an 11. Okay, C would have to equal 11. Okay, how about ZWX, or what we've labeled with a B? That angle right there, what would B have to be equal to? Well, angle ZWX, this angle right here, should be congruent to an opposite angle, which is from here all the way to here. okay, which includes the 18 degrees and the 39 degrees. Okay, so altogether this angle over here equals 49 degrees, 18 and 31. So if that angle, angle y, zy to x, that angle, if that angle equals 49, what do you think angle zwx equals? Well, has to be the 49, according to the properties of our parallelograms. Opposite angles are congruent. And last but not least, angle W there and angle X are what you would call consecutive, which means angle W, that 49 degrees, plus angle X, I'm just going to call it X, even though that's not completely accurate. Actually, let's call it D, since that's the letter that's representing that angle, equals 180. Consecutive angles are supplementary. So I subtract the 140, or the 49, subtract 49, subtracting 49, and D equals 131. Woo, we get the answer, yay! Okay, so D in this problem equals 131. Now, these videos, if there's anything you're like, what, wait, how did he do that? These videos are on YouTube, and I have sent you guys an email. If I had your email, if you were in the system, I sent out an email with a link to all of these YouTube videos, okay? I also have the videos saved on a flash drive that is in my desk, and Miss Ellison would know where to find that. But all of these videos are on YouTube, and I've sent out the links on where to find them. If you are sitting at home or you've got time somewhere or whatever, and you're like, I don't really remember what Mr. Hahn said about this thing, then you can look up the video and watch it at your own speed. You can watch it and say, wait a second, what did he just say? And rewind the video and play it again. It's the beauty of videos, okay? You can rewind them, rewatch them, watch them as many times as you need to, okay? If there's time at the end of class, you guys can also rewind this video and find instructions that you may have missed. So, that's what you guys, you have these videos, you have access to them, please use them, okay? Tomorrow you will practice everything we just learned about parallelograms, okay? And I want you to be mindful of all the stuff we've learned about parallel lines, about triangles, about polygons in general, okay? Remember all that stuff. You can't forget it just because we've moved on to a new topic. All right, so you guys have a great rest of the day. You guys will have another video on Wednesday, but tomorrow you will practice parallelograms. All right.